All right, good morning. Welcome to the 2026 Ham-cation AMSAT Forum. My name is Drew Glasbrenner. I'm a full-time Kilo Officer for Mike Alpha. Most of you guys know me. Good to see you. Thanks for coming. Looks like we got a full house. Normally, I would stand up and be really animated, but I'm not going to lie to you. I'm as tired as a newborn puppy, so I'm going to sit down for most of this. I put together a presentation for you guys in two parts. The first part, the question that I always get is what satellites can I work right now? So the master key to this question is the AMSAT status page. You go to amsat.org/status, and there's this really cool user-driven graph that tells you every 2 hours people can report if they've heard satellite. If they heard the telemetry, if the uplink and downlink is active. In the case of the ISS, if the astronauts are on the radio, or if they didn't hear it. And it's all color coded. So you can go in and make reports. And the nicest thing about this is, I know you guys can't see this little teeny tiny type, but say the first satellite, 80123, that was the FM repeater that we worked first thing this morning outside the booth. It's on a schedule, it's not always on. And it's a Russian satellite, so sometimes the information can be hard to find. Well, you can come right here and say, yeah, February 10th, today or yesterday, whenever I made this graph, it's been reported on, so let's give it a try. Same way, AO7. AO7 bounces between mode A and mode B, depending on the illumination status. You can see here that it's reporting on in mode B. And if it had been on in A, there would be a mode A column or row there. So write that one down. That is the key to finding out what's going on. And we've had that page for a long time, but there's really a lot of users now, and it's really a good resource. So the rest of the first half of this, I'm just going to go through the satellites that you can go out and make a contact on this week. Because I hear quite often that there's no satellites up there. Well, yeah, they're on. So we're going to point them out to you. We mentioned this earlier. Did a great demo this morning on it. 80123, also known as ASRTU-1. This is a big CubeSat. I think it's a 12U. I forget exactly how big, but bigger than normal CubeSat. It's got a VHF uplink, UHF downlink, FM repeater. They send digital slow scan images on the UHF telemetry channel, and it has a high-speed X-band 10 gig data downlink. That usually is only on over Russia, but maybe we'll see more use on that. Scheduled operation, so you have to check the status page, see if it's on. They also have an account that on X that you can follow. Just search for ASRTU-1, and they also post the activations there. 8073, also known as FunCube. This has a UHF up, VHF down linear transponder. It's been in orbit 12 or 13 years. It's a great little satellite. It's the first 1U CubeSat to have a linear transponder in it. The uplink drifts a little bit on this. They fixed it on newer FunCube satellites. So you can't use your computer tuning on this. You'll have to shut it off and tune the uplink manually to keep your signal on your downlink frequency. But it works great. AO7 is still active. I'd like to make a joke about being 1 month older than AO7. The satellite is 51 years old. Launched in November 1974. The batteries failed on it sometime in the early 80s. And then I think it was 2002 or 2003, somebody started hearing the CW beacon. And we could actually hear the CW beacon bumping on the uplink to UO14, which was an FM satellite. So we figured out that apparently the batteries had went open circuit. So now when it's in sunlight, it runs off of the solar panels. So we got a satellite back. What's really nice about AO7 is it is at 1,450 kilometers. It's currently the highest altitude out of any of the operating satellites. What that means is from Florida, it's fairly easy to work in Western Europe. You can work, if you've got capable stations on both ends, you can work Hawaii, you can work Alaska. I've worked as far south as Buenos Aires, Argentina on AO7. It's a great satellite. It's a little quirky. It only runs in full-size sunlight, or it only runs when it has sunlight. So luckily, most of the time, that's the whole orbit. It's high enough and it's close enough to the terminator that it's got illumination most of the time. When it is in continuous illumination, there's a timer on board. There's no computers on the satellite. There's a timer on board that switches it between mode A, which is 2 meters up, 10 meters down, and mode B, which is, in this case, 432. It was before we had separate satellite subbands, and 2 meters down. So mode A and what we used to call mode B, it switches between it every 24 hours. That's a good thing to go and check the sat status page, because when it's doing that, you can see where it alternates and you can get an idea of time where it switches. Right now it's going through small eclipses, so it's in mode B most of the time. AO7, because it's running off the panels, we want to be real easy on the uplink power. 5 watts is plenty most of the time. We want to be super careful with CW and constant Newton data uplinks, like FT4, which is becoming popular on the satellites. FT4 and CW is really hard on the satellite, and hit it too hard, it resets. And it may reset into a different mode until it hits another eclipse and repeats. So AO7 is still a great resource after 50 years. AO91, which was the second of our Fox series and FM satellites, it is still partially operational. It's getting close to the end. It's kind of circling the drain. The batteries are pretty much shot on it. It works in sunlight only and only occasionally. But it has good days and it has bad days. And when it's on a good day, it's a great little repeater satellite. FO29 is also kind of in the same boat as AO7 and AO91. Batteries aren't great on it. It's been up there a long time. I think it was launched in '94. Operates in sunlight only, and it has to be turned on by the ground station in Japan. This is Fuji-OSCAR. It's controlled by the Japanese amateur radio. The nice thing is very soon, early March, I think March 9th it is, coming into full illumination, so it'll stay on. So take a look for this one in a couple of weeks, and it'll probably be there. 2 meters up, 77 meters down, linear transponder, 100 kilohertz wide. This is probably one of the best LEO satellites that we've had. JO97, we did a demo on this morning, and then yesterday morning, it was the sideband transponder that we worked. This is a Jordanian satellite with a amateur radio transponder built by AMSAT UK. Great satellite, works really well. UHF up, VHF down, it's a transponder. So sideband CW and low duty cycle, low power, low duty cycle data modes. Of course, if you guys were in here for the ARIS presentation, the ISS is up there. We have the opportunity for live QSOs, the VU repeater, the VHF APRS, the VHF SSTV that they do, and the S-band ATV, Ham-TV. You guys probably just sat through that presentation, so we'll move right on from there. But what a great resource. At 10 watts, you can hear it on a wet noodle. PO101, also known as DAWATA-2, is a Filipino microsat. I think about 40 kilograms, pretty big satellite. It has a UV repeater built into it, 77 meters up, 2 meters down. It's scheduled operation. It used to be pretty much every afternoon on the descending passes it was on. It's been here and there lately, so another one to either check their X account for the announcements of their operation times, or take a look at the status page. QMKWT2, QMRKWT2, what a mouthful. Also known as RS-95S. This is the 1U CubeSat from, I forgot what country. Yeah, Russians are involved in it, but there's a Middle Eastern, Kuwait, sorry, KWT, Kuwaiti involvement in it too. It is in commissioning right now. It was just launched a month or so ago. It has a VU repeater on it. Very, very nice repeater. Sounds very good. Pretty strong. I think it's like a 500 milliwatt downlink. The last 3 Saturdays they've turned it on. I didn't hear it this morning, but I think I saw a post on X that they had an issue with turning it on or something, and we're going to do it later. Scheduled operation. There's their X orbital space. Is their account. If you follow me or follow AMSAT on X, I retweet a lot of this just to get the information out there. And then you can find the individual ones you want to follow and keep up to date with them. Little 1U CubeSat. So I expect we'll see some more operation and more regular operation out of this soon. Here's the queen of the fleet right now. RS-44 has a 60 kilohertz wide, 2 meter up, 70 centimeter down transponder. So we see a lot of sidebands, some CW, and way down at the bottom of the passband, we see quite a bit of FT4 operation. So this satellite has a great footprint. The Russians do not pay any attention to orbital debris regulations. It's in 1350 or 1300, somewhere around there. It's a nice footprint, big high footprint. Just a little side note, this is kind of interesting. This satellite is still attached to the upper stage of the rocket that launched it. It didn't detach. And unlike the satellites we build that have physical kill switches to keep them off while they're attached to the booster, they don't. So they turned it on, and it's attached to the nose of the booster. And this is conjecture on my part. I'm assuming the business end of the booster is probably heavier than the top end of the booster. So the heavy part leaves in orbit. And on an exactly due south to north pass, I have a hard time hearing it if it's exactly, because it's on the back side of the rocket body. As soon as it goes overhead, bang, it's super loud. But that's only on like right down the barrel type pass. It's off to the side. It's easy to hear. It's a great satellite. We did some demos on this one this morning and yesterday morning. This is SO-125, also known as Hades-ICM. This is from AMSAT Spain. This is a pocket cube. This whole satellite, the body of the satellite, is 5 centimeters. It's 2 inches. 2 inches by 2 inches by 7.5. You do the math on it. So, 3.5, 3.75 inches. It's smaller than your fist. It's like a big salt shaker. And then you've got the antennas deployed off of it. It has a VU repeater on it. It has RIDI telemetry. They do all sorts of little interesting experiments with it, but primarily it's a FM repeater satellite. Great little satellite. SO-50, SAUDISAT 1C. VU repeater, always available. It's an older satellite. It's at 650 or 700 kilometers. It's got a good footprint. It's the highest FM satellite we've got right now. It has tone access, so you have to program a PL tone. But this is a great satellite. It's been around for a long time. And for some reason, it doesn't see as much use as you would expect it to. It's a little bit harder to hear. It's only 250 milliwatts downlink. That's why it's lasted as long as it has. This is an interesting satellite. This is SONIC 2. This is from a German university. It also runs schedule. They have a web page. Occasionally they tweet or post on X. It has a VHF 1200 baud digipeter on it on 145 HQ5. And some weekends they send slow scan down on the VHF frequency. I think it's 145 HQ8. And we have a whole slew of Russian student satellites that are affiliated with SpacePod, which is a Russian organization for CubeSats. Most of them at some time send slow scan images down. We copied a couple this morning off of RS-40. So this is all scheduled. Excuse me. The images are all loaded from the ground. There's no live images that we've seen yet on any of these. It's pretty cool. They have some, over Christmas time, they had a little game where they uploaded an image that had like a little cryptographic game to it. It's pretty cool. There's a new one, the picture of the sea turtle down the bottom left. It's a joint mission with the Ecuador, Galapagos Islands. So they were sending pictures right after launch from the Galapagos, which is nice, neat stuff. So that's the rundown on what's up there. I didn't cover everything. There's new satellites being launched all the time. Access to orbit, if you have the money, is pretty easy right now if you just want to go to 550 kilometers. So there's a lot of student satellites. We're going to talk more about how AMSAT's trying to leverage that in a more real two-way amateur radio satellites. Let me take a break and get a drink here. Anybody got a question while we're at this point? Yes, sir.
Any word on when it's about to system is going to be on?
TEVEL 2, we haven't got a lot of communications from them. They tested some and they were having some issues with the software on the satellites. Off the record, TEVEL 2, every satellite's controlled by a different high schooler. As someone who has a middle schooler and a high schooler, they aren't the most reliable people on the planet. But I would expect sometimes we'll see some of those activated again. I'm very anxious to see that. The TEVEL 2, there's 8 or 9 LEO satellites, all identical 3U. They have the capability to be FM repeaters. They were activated a couple of times, and we haven't seen a whole lot in several months. So hopefully we'll get some of those back soon.
First batch, a few weeks after they launched, they were all activated. The second batch, and then they all eventually deorbited. The meetings, I have really good hopes, but it's been months since they were done.
Yeah, different people in charge of these.
Oh, okay.
There was one volunteer that was activating all the first batch. So part 2, what's AMSAT doing? This is probably the second most question we get. So for anybody who's a member, you may recognize the order in what I'm talking about here because I put it all out in my last Apogee view, which is the president's column in the AMSAT journal. So we're just going to go through all of our major projects, not all of our projects, but our major projects, and give you an idea of what all we're up to. We're going to start out with AMSAT Education. For those of you that don't know, AMSAT builds and sells kits for CubeSat simulators. These are really neat 1U cubes that have everything that a real satellite would have inside it: batteries, solar panels, telemetry, command capability. The newer versions even have FM repeaters that you can activate in them. You can turn different types of telemetry on. There's a camera in them that sends slow scan. This is the right side of the booth. If you've been to our booth here over in the main building, the right side has several of these CubeSat simulators set up and running. We also have a CubeSat Lite, which is a 1-board or 2-board miniature version of this that omits a lot of the solar panels and things. It's much cheaper to make it much more available to organizations that might not have funding to buy the big one. So we've got these on display over at the AMSAT booth. This is Alan Johnston's baby. He's our Vice President of Educational Relations. And at CubeSatSim.org, there's this, if you're a teacher or if you're teacher adjacent or if you work with kids, there's a great guide to using satellites in the classroom. It's like 113 pages PDF, really, really nice gathering material to use satellites to get kids excited about space and about STEM. And that's available for free at CubeSatSim.org. So we're stepping up production of these CubeSat kits. In years past, when we've had them available, they sell out really quick. So we're like quadrupling production of them, so more of them will be available. The AMSAT Youth Initiative is doing a lot of great work. We are a 501c3 educational foundation. The AMSAT Youth Initiative just recently published a set of free online courses for students. The theme is Satellites in Space Help Us Live a Better Life on Earth. They're a neat little online learning. You go through and answer the questions and you learn about different aspects of satellites. The first one was satellite meteorology. There's several other ones that have been released, and we have a list of about, I think, 30 of these that we're going to do. Those are available for free at buzzsat.com. And also part of the Youth Initiative is we have a satellite-themed coloring book that's going to be released soon, free to kids, teach them about satellites. This thing obviously aimed at elementary school kids, and get them involved and maybe some interest in getting involved in AMSAT. One of the things we did at the AMSAT Board of Directors meeting in October this year is that we made membership in the AMSAT free for students. So anybody 25 and younger that is a student, and we do look for proof that you're a student, your address or tell us what you're studying. Should have an AMSAT membership for free. If we want to grow and build the organization and ensure that it exists past the current generation, we have to get kids interested in it and make them pay money to join an organization. It's not that we can do that. So if you got a kid and you want to get them interested in satellites, and if they show a spark, sign them up for a membership in AMSAT. Our main project right now is AMSAT GOLF-TEE. Greater orbit, larger footprint, if you want to look at a acronym that we call. We name all of our projects with the alphabetical tags until they get into orbit, where golf, but greater orbit, larger footprint fits this one. Basically, the point of GOLF-TEE is learn how to operate a satellite that is not just a cube with a magnet and to orient. This satellite has 3-axis control, which means we can point the satellite where we want it to point. It has expandable, unfolding solar panels that will generate up to about 40 watts. We can use the attitude control to point those at the sun as we go around the Earth. For reference, a 1U CubeSat makes about 2 watts. This is a 3U that's going to make about 40 watts. So we're going to have a lot of power to do things with. There's a standard VU transponder on it. There's also on the first one, there'll be an X-band high-speed download. And then we have a radiation tolerant IHU that we're testing. If we want to go higher, we have to be able to tolerate radiation. And this is testing an IHU that's radiation tolerant that we put together. This satellite was originally supposed to launch on a NASA-funded CSLI launch. Last year, the cuts initiated by the administration eliminated CSLI launches that weren't already manifested, and we haven't manifested yet. We're going to hear next month whether that launch may come back or not. If it doesn't, we'll be putting the bill for a launch to LEO for this. About $130,000 for use of LEO, somewhere in that ballpark. So we'll be looking for grants, we'll be looking for fundraising, we'll be looking for support to get this into orbit. And the idea here is to learn how to do things like 3-axis control and sun point modes, so we can go higher and do better things with this satellite. At the same time, we're also working on a series of 1U satellites called FoxPlus. The first one of these will be ready this year for launch. The first 2 satellites in this series, we bought some commercial hardware to try to speed the process up. That hardware includes the frame, the solar cells, the EPS, the power system. And of course, they don't plug together with our stuff. So we had to build an adapter, a mechanical adapter to hold our boards, and also a power signal adapter to go to the ISIS space boards. But these will be LEO satellites. The first one will go with probably with our LTM-1, a linear transponder module, 30 kilohertz wide VHF, UHF transponder. We're looking for commercial launches for these, and we've got one that we've already kind of put a hold on. Looks like we might be launching with AMSAT UK's 2U Funky Plus. So two of us may go together in the same pod on a to be determined launch date. The AMSAT LTM-1 is a 3-board 1U CubeSat form factor stack that has a 30 kilohertz wide linear transponder, 1200 baud BPSK telemetry, and an integrated command receiver, and actually a little IH2 in here too. We've flown these 3 times before. The first one to orbit was the second version, and sometimes it happens that way, on HuskySat HO107. The first version flew on AO109. We had a little issue with that one. The finals on the transponder failed, and it was very low power, but you could do CW and digital modes through it. We fixed that problem when we flew it on MainSat-1, which later became MO122, and it was operational for about a year and a half, providing good transponder service. For some reason, it wasn't very popular. Not a lot of people knew about it. And it went silent a couple of months ago. We don't think it was the radio. There were no problems in the telemetry. For this satellite, we built the radio, and students built the rest of it. So there's a lot of other things that can fail on a satellite to kill another's radio, so we don't know. Well, we got a year and a half out of it. It was a good satellite. So we're happy with the LTM now, and we're going into almost mass production. We've got 5 of them that we're building right now. We've found 2 partners so far that are a sure thing to fly with, and I'm in talks with a couple other ones. The idea here is that we build the radio, we give it to the student satellites. The student satellites fly it because they have funding from launches and they need a radio. You know, if they go to a commercial vendor, it's 5 digits to buy a radio, or they can come here and get it for free. So they get it for free, and the quid pro quo is they run the transponder. Maybe not all the time, but as much as possible. You know, it's not something that they're going to turn on for a couple of days, a month, or something like that. It needs to be continuous operation, or as close to it as they can come. Basically, a transponder and every student satellite. So we've got 5 of these that we're building right now. I think that we'll probably build another 5 real soon, and hopefully we'll start seeing them in all our student satellites, and there'll be a lot more opportunities to use a transponder. Separate from providing them to universities, I'm also looking to fly them on other satellites as hosted payloads. One of the organizations we're talking to is a government organization that builds and flies satellites, and they have extra room. They build 6U satellites, and quite often they only launch 3 or 4U worth of volume. We're a third of a U. So we're talking to them about including this transponder into their next satellite, maybe series of satellites. Basically, these are technology demo satellites. They have one major payload, they launch and test the payload, and maybe they're active for a month or 2. So we'll use up all that power for the rest of the lifetime. Another AMSAT project is the PACSAT Board. This is basically we took a 1980s, 1990s PACSAT, packet store and forward satellite, and shrunk it down into one board. So we have 4 VHF uplinks and a UHF downlink. The chips that they're using directly convert from RF to data, right on board one little chip. They do different modes. We can do AFSK, APSK. I'm not 100% versed in this, but it's very versatile. That was part of the design. The payloads, it's a payload. It's not a satellite on its own. So these will be hosted Let me tell you something about student university satellites, what we see happening now. I also volunteer for the IARU Frequency Coordination Committee. So all these student satellites submit to us and we kind of sort out so that you don't end up with satellites with conflicting frequencies on the same launch or in orbit. So we see all these when they're starting. Some of these schools that are building satellites don't even have ground stations. They're hiring out ground station time on the Amazon network or some other commercial networks that will download data from their satellites as a service. Some of them fall into the trap of thinking, well, I've only got 15 minutes on one pass, 2 passes a day to download a huge amount of data. They don't always integrate into the community as well. With a payload like this, anybody that used to work with PACSATs remembers that you can have a huge file and you get part of it this pass, part of it the next pass. Joe in Australia can get part of it. The software that AMSAT has created to be the back end of this takes all of that data and it's submitted via the internet. It compiles it all into one source. So these kids don't have to pay Jeff Bezos to be their ground station. They can have hams that are using the store and forward pack payload download their science data. So that's where I see this headed. This is going to be very popular once people get an idea of what you can do with it. And it's an old system built on new technology. So, what used to be an entire, anybody that's seen the microsats remembers that they were trays stacked. What used to be a 1 foot by 1 foot by 3 or 4 inch tray is now a one PC board that's 10 millimeters high and 10 centimeters square, or 30 millimeters high. So the first batch of these are in production right now, and we're in talks with at least one school to fly it very soon. SDR Gen2. So on the Golf Series satellites, excuse me. On the Golf Series satellites, we have an Edis 310 board, I think it is in there, that does some of the signal generation for the X-band download and some other stuff. This is a different version of the same sort of thing. It's an SDR board. It can be run as all modes, all bands. We put up, it's 2 meters to 6 gig. We put an up converter on it to do 10 gig downlink, real high speed data. This is something that we're working on. It started out as SDR Plan B in case the Edis board didn't work out, but it's SDR Gen2 and we've got a team working on that. ESA futureGEO. For those that don't know, there is a Qatari TV broadcasting satellite parked over the Middle East that has 2 amateur S-band up 10 gig down transponders on it. AMSAT DL coordinated this with the Qatari broadcasting company. It is a wonderful resource for amateur radio operators to make contacts through a geostationary satellite. Unfortunately, we're fresh out of oil sheiks on this side of the pond, but we're still working to find some way to get something to a higher orbit. ESA is starting to talk about a follow-on project that would duplicate and expand the capabilities of QO100, the Qatari satellite. ESA, European Space Agency, wants to serve the ESA members and associate members. Well, the US isn't a member of ESA, but Canada is. Canada is an associate member of ESA. So they have suggested that Canada, or as much as Canada as possible, is included in the flow agreement. Boy, that works out pretty good for us. So, thank you, Canada, for being an associate member of ESA. There were a batch of initial proposals. AMSAT us, people call us AMSAT North America. We're not. we're AMSAT. We don't represent Canada anymore, although we welcome Canadian members. Canada spun up their own AMSAT group, partially in response to this. So we're AMSAT. We participated with AMSAT UK in one of the initial proposals. And then I attended a meeting virtually with AMSAT DL with the idea of trying to pull a bunch of these proposals together. What we're looking at probably is going to be a 2 gig uplink and a 10 gig downlink, and then some higher bands and maybe a camera. That's sort of the general consensus that came out of the meeting. Before, it used to be when you said microwave or 10 gig, people gasped, you know, oh, that's tough. Well, the 10 gig downlink is not. You get an LMB off of eBay or broadcast TV, satellite broadcast TV, which is at 12 gig. You hook it up to your SDR receiver and find out what frequency 2.4 is coming out at, or 10 gig is coming out at, and boom, there's your download. Stick it on a dish, you're done. It's not tough. And 2.4 is a little harder to generate a signal, but there's plenty of cheap 2.4 gig amplifiers and antennas out there built for Wi-Fi that are usable on QO100. And there's a lot of SDRs now that generate an uplink signal at 2.4 that you can then feed into a little Wi-Fi amplifier. We're also talking about maybe 5 gig uplink on this, which is some of our previous proposals for GEO satellites and GEO payloads were 5 gig up and 10 gig down. 5 gig is awful close to another Wi-Fi band, so there's a lot of hardware out there for that too. So far, this is still just in the talk stage. We are involved, but we are not in a position to dictate or tell or ask anything. We're hangers-on this one. We'll try to have input on it as it goes along. It's not funded, you know. This egg isn't anywhere close to hatching, but it's a possibility. So we've got our finger in the mix, and we're going to try to keep up with this as it goes on. I don't have a slide for this, but I've only been president since October, but I've been involved with AMSAT for 20 plus years. I've been vice president of operations for almost 20 years. That's now Mark Hammond, who you probably met in the booth. One of my primary goals is to find a way for us to get back to higher orbits. This has been really tough, really tough. There's a lot of opportunities opening up now, but they take money. There's companies that are flying hosted payload platforms to GEO or to drifting GEO orbit. We could be on those, but we have to have enough zeros in our bank account to make that happen. These are commercial opportunities. We don't have the same sort of freebie because nobody else is using the space opportunities that we had 20 and 30 or 40 years ago. Space is very commercialized, and to quote Dr. Tom Clark, no bucks, no buck Rogers. And we really have to find the opportunity and then find a way to fund that. Luckily, we have a good relationship with ARDC. We can look to them for some grants for specific projects once we find the opportunities. But this is my primary mission as president of AMSAT, is to get us back to some higher orbit opportunities. With that being said, AMSAT runs on donations and membership. We have made a huge steps forward in saving money. Our office manager, Martha, retired several years ago. We closed our brick and mortar office in Washington. We run on a distributed system. Our membership is handled via the online portal where you can go and update your own membership and pay online. We're trying everything we can to save money. I just recently canceled a meeting where everybody was supposed to get together in a couple of weeks to do some strategic planning. We can do that where we need to save our nickels and dimes for when we get a chance to build something and launch something bigger than we have. That being said, we need your membership and your donations. AMSAT has about 4,000 members. Just as a analogy, I run the AMSAT Facebook group that has almost 19,000 members. That's 19,000 people that have expressed an interest in the amateur satellite program, and at least 15,000 of them are members. So we'd like to have you as a member. We'd like to have your support in terms of volunteerism and donation, and we need that to keep amateur radio in space. If you go to launch.amsat.org, that's our online membership, and you can sign up there. Right now, we're giving away a digital copy of Getting Started with Amateur Satellites. This is 100 and something pages of the best, newest satellite information out there. So if you're just getting started, or if you're coming back after a long break, this book is a good way to get back up to speed. We have these for $30 printed in the booth. They're $45 if you want to order a printed one off the webpage because of shipping, or $15 for the digital version, or you get it free with membership. So I'd like to have your support, and thank you for your consideration. Membership is $44 a year. We have a journal that comes out every 2 months, electronic. That was another cost-saving measure. We were spending more money to print the journal on dead trees and email it around the country than we were taking in membership, so that hasn't changed. But it's a good digital journal. It's emailed out via PDF every 2 months. The other things we do, we provide Keplerian elements for all your software tracking programs. We represent you in Washington when things come up with the FCC or with new rules. We have used to be called area coordinators, AMSAT ambassadors that are out there in the field, people that you can contact to help you with getting your satellite stuff running and learn how to operate satellites. Those are the guys you see at the Ham Fests, doing demos with HD and the arrows and sitting in the booth and giving presentations like this one. So, and there's a lot more that AMSAT does, but primarily I want to get a lot of new hardware in orbit for you guys to use. Any questions? Yes, sir.
This comment that journal or magazine is really well done. It's very well done with a lot of information. It's substantial.
Yeah, thank you. He was just saying that he enjoys the journal and it's got a lot in it. And we can always use more. One of the things that every organization is dealing with is, as social media has advanced or evolved, depending on how you want to look at it, people who used to write articles and send it in journals and newsletters and things like that, now they publish it on their own blog, and that's okay. That's cool. That's free, open access. I'm all about that. But you know what? Send a copy to us and we'll put it in our journal too, and that'll get you a new audience. We'll take anything satellite related, even if it's just, hey, me and my kids did a Rick Rover trip, and here's some pictures, and here's some satellites. Anything. We're happy to have any and all content. Any other questions? All right, let's give some stuff away. Let me look here. Who's the youngest licensed amateur in the room? Anybody? 79. 79. You're on the wrong end, my friend. Anybody in their 20s with a ham license? We got one in their 20s? Come on up here, bud. You young man, you're going to get a ham license, right? Yeah, come on up here. Come on up. You're going to get a hat. Are you on satellites now?
I have not been yet.
Getting started, though. Okay. All right. Here's okay. For the other end of the crowd, who's been an AMSAT member for 30 years? Continuous. Now let's go with, when were you first an AMSAT member? 30 years?
Oscar 7, 1980.
Okay. Oscar 7, 74.
Well, that's my end.
Okay, 1980. Anybody been a member since before then? Come on, get a t-shirt.
Another question is, will it fit?
This is an XL. We got two XLs if you want to swap them. Maybe I just How about the, let's see, what's another one? Who here has, I got myself in the corner here, didn't I? Who worked Oster 6? Anybody in here make your contact on Oster 6? Lou. Lou's the only one to raise your hand. Come get a t-shirt, Lou. We wanted it to be nice to both ends. You guys in the middle like me are just, I don't know. There's no good criteria there. If that don't fit, you can swap other ways. Yeah? Cool. Well, thank you guys. Stop by the booth. We got lots of other shirts and hats and stuff. Sign up for membership on the online portal and come see us tomorrow morning. We'll do a couple more demos. Thank you.